When we look at human cognitive evolution, we often assume that it had finished evolving by the late Upper Paleolithic, when we start seeing really interesting things like art and burials. Certainly, we assume that it hasn't changed all that much in the last 10,000 years. And I study things that are much more recent than that, 5,000 or 6,000 years ago, and I find them very revealing. They specifically reveal that human cognition continues to change. And I'm going to look at a recent technology, writing, and it's going to show how and why our interactions with material forms can influence our behaviors and brains, as well as the form and functions of our tools. Today, we see writing as a means of symbolically encoding, preserving, and transmitting knowledge across space and time, and literacy as the ability to read and write such symbols. We don't think of writing as a material form, nor literacy as a cognitive state that depends on interacting with that material form. Simply being literate means acquiring a set of specific behavioral and neurological changes. These changes are acquired when someone learns to read and write, and being able to read and write demonstrates that these changes have been acquired. These changes enable someone to interact with a specific material form, which of course is writing, and interacting with that material form is how these changes are acquired. Seeing writing as a material form lets us examine how and why it has changed over time. This change is interpreted through insights gained from neuroscience. Such descriptive pattern analysis requires two things. First, a material record that can show material change at the level of detail needed for analysis. And second, a cognitive state understood well enough that change in material form can suggest change in behaviors and brains. With Mesopotamian writing and literacy, we have both. Early writing consisted of small pictures with approximate meanings. They were relatively accessible because reading them did not involve significant behavioral or neurological change. In contrast, scripts are written forms that involve and depend upon specific behavioral and neurological reorganizations. Scripts can't be read without the specific reorganizations that comprise literacy. A significant difference between the two states is that writing can be invented, but scripts cannot be. For scripts to function, the specific reorganizations must already be in place, something that cannot occur until writing has first been invented and interacted with long enough for behaviors and brains to change. Instead of invention, script emerged gradually from interactions with writing sustained over generations. Let's start with the way the brain changes in literacy. In a literate brain, the fusiform gyrus recognizes written characters by leveraging the capacity for recognizing objects and faces. It also interacts with Exner's area, the motor region that plans and executes the movements specific to handwriting. The functionality of this region enables us not only to produce written characters, but recognize them as well, a point I will return to later. The fusiform gyrus also interacts with the functions that produce and comprehend speech. The interactions between these regions associate written characters with the meanings, sounds, and structures of language. We recognize objects topologically, that is, through combinations of their structural features and spatial relations, combinations that are mentally instantiated into meaningful identifications. Simply, object recognition involves both visible features and mental processing. For example, here you might see a cube where the lines are constructed mentally from the visible features. Local features are the circles and cutouts, while global features are the relations between them. The characters, the features and relations are still there, even when the object is deformed. Character recognition is similar. You likely see the words "the cat," though the middle characters are both deformed. Recognition and meaning involve topological recognition of the characters, the context provided by the adjacent characters, and learned associations with language. Early writing consisted of small pictures that meant what they looked like, or something related to them. So a picture of a head could mean head, person, or capital. There were also conventional signs. These meant what everyone agreed they meant. So the quartered circle meant sheep. By some 6 centuries later, signs had lost much of their resemblance to the objects they had once depicted. As writers learned to recognize characters topologically, the need for the characters to preserve their original forms was relaxed. This in turn freed them as a set to converge on features that enabled them to be discriminated and individuated. Discrimination is telling characters apart from one another, while individuation is identifying a character for what it is. As is true of writing today, discrimination and individuation involve topological recognition. Now, the features that differentiated early written forms were obvious, while those of script were far more subtle. Discriminating and individuating characters with subtle differences requires familiarity. With familiarity, objects become easier to tell apart and identify, so the clues that distinguish them can become more subtle. In turn, subtle clues mean that training and practice are needed to gain familiarity. These effects are found in other domains like facial recognition, where familiarity affects matters like eyewitness identifications. The difference is that the features of written characters are malleable and thus adjustable as a set, something the features of objects like faces are not. Characters also lost some of their detail, suggesting an optimization or balance of local and global detail. Local detail helps novices discriminate and individuate characters. However, it also slows proficient readers who make greater use of global cues, which is something novices find difficult to do. Simply, the more detail characters have, the longer it takes not just to write, but also read them. Today, this same effect is seen in diacritics in African tonal languages and Hebrew vowels. Both have 2 written forms, one with diacritics for novices and one without for masters. The trade-off being that readers have to learn both. A single form, in comparison, implies a compromise between the 2. Writing by hand was critical to these developments. Today, we still learn to recognize written characters by interacting with the material form of writing. Simply, we practice until we become proficient at production and recognition, just like ancient writers did. And just like it did for them, handwriting changes our behaviors and brains by improving our fine motor skills, hand-eye coordination, lexical retrieval, recognition and recall functions, and tolerance for ambiguity in written forms. In the historical development of writing, handwriting afforded the habituation that standardized how characters were formed and automated their production. Most importantly, handwriting allowed for the continual adjustment of the material form. This was essential to the system's ability to change, as the material form changed in ways that reflected, accumulated, and distributed incremental change in behaviors and brains. About 15 centuries after writing began, a form of cursive developed. Cursive is a form of writing in which all the letters of a word are connected to each other. It contrasts with block print, where letters are not connected. Cursive can be written more quickly, and faster movement produces writing that is more likely to be sloppy and thus ambiguous in form. Being able to read something with ambiguous form is a training effect gained through handwriting practice. Tolerance for ambiguity is simply the ability to recognize characters topologically despite their increasing deformation. Writing that is sloppy but readable through a developed tolerance for ambiguity means that production can become quicker. And in turn, quicker production means that writing can keep up better with the pace of thought, which makes it a tool that can interact with mental content. Standardization is forming each character with particular strokes in particular order. When writing first began, there was no such protocol. Over time, the strokes used in the characters and the order in which they were made became increasingly standardized, and standardization shows handwriting behavior becoming automatic. Automaticity frees up cognitive resources like attention and working memory. Simply, automated behaviors do not require the kind of sustained, dedicated attention that unfamiliar behaviors do. We experience this same thing when we learn to drive. At first, we must attend closely to operating the car and conditions on the road. As we gain proficiency, however, we pay less attention to these things, becoming alert only when conditions change. In writing, automaticity lets us focus on what we're writing rather than how we're writing. Increased attention to the content of writing rather than the mechanics of production helped transform writing into a tool that could engage mental content directly. Writing began as small pictures whose resemblance had a range of meanings. As writers practiced, they produced signs with greater standardization. Topological recognition relaxed the need to preserve form, so characters deformed and converged on points of contrast under the influence of things like familiarity and automaticity. Signs simplified as proficiency in using global cues reduced the need for local detail. Signs changed from forms whose meanings could be approximated with minimal training to forms that required specific behavioral and neurological changes to read and write. Now, I've omitted a lot of key details, like how sound values are incorporated into writing and how and why numbers are different. But by 2000 BC, literacy is signaled by several phenomena. Words were no longer split between lines of text, an integrity of form that implies topological recognition. Cursive developed, demonstrating tolerance for ambiguity and gaining speed of production. Writing was applied to many new purposes, an expressive power that shows a focus on content, not production. Training was highly formalized because script could no longer be read without it. And finally, the types and rate of change also decreased around this time. Analyzing writing as a material form shows that interacting with material forms changes behaviors in brains, and this influences material form and function. Such change is incremental, and over time it yields a tool that cannot be invented, but only realized through sustained communal use. What the material form does during this process is realize, accumulate, and distribute incremental change in behaviors in brains. Each individual and generation has a simple task, which is learning and using the tool in whatever form it currently has. Changes in behaviors in brains are implicit to learning the tool, while changes in material form and function occur through its use. These insights suggest that we expanded the way we model cognitive aspects of tool use, something traditionally modeled on the individual, the classic example being blacksmithing and arguably making pottery. The individual model emphasizes the acquisition of skill and expertise, looks for aha moments creating insight, and is very interested in the individual engagement of brain, body, and material form. The individual model does not, however, represent social aspects of tool use, where behaviors and brains change together. The material form accumulates and distributes those changes, and material form and function emerge through the sustained collaborative use. Though behaviors and brains have much in common, people differ in their psychological, physiological, and behavioral attributes. Most of this individual variability cancels itself out. Highs simply counteract lows. And this keeps tool form and function synchronized to average capacities. Cumulative variability yields tools that remain widely accessible despite change in form and function. Writing, and by extension other material forms, provides a mechanism for cognitive change of a type that can be acquired only by interacting in a specific way with a specific material form. In this case, literacy cannot be learned through observation or gained through explanation. If people stopped interacting with the material form of writing, literacy would vanish in a generation. So literacy is a culturally acquired cognitive state that persists because we continue to engage the material form of writing. An interesting question is whether such materially acquired cognitive change yields longer-term effects. I mentioned earlier Exner's area, the region associated with the motor movements specific to handwriting. Exner's area also plays a role in character recognition, irrespective of whether the characters are handwritten or typed, and regardless of whether the hands and arms are even moved. Simply, Exner's area responds to the material form of writing in a way that transcends both the original motor activity and the original material form. This suggests that human thought is deeply tied to the engagement of material forms. It also suggests that our lineage has developed a generalized neurological response to material culture that is perpetuated by interacting with material forms, even those far removed in form and function from the tools our ancestors once used. This research suggests that our behaviors and brains continue to change up to the present moment through our use of material forms, just as the change in our behaviors and brains continues to influence their form and function. Thanks very much for your attention.
Thank you so